Your essential questions for today is how do we graph exponential functions? We are going to be graphing them. We are going to be relying on our calculator to help us type these in. So it's not a difficult lesson. It's just making sure you know to type it in. Guys, the main thing and what you're going to see on the quiz and the test is it's going to say make a table. Make a table. And so that way we're all staying consistent. We're going to make the same table each time. We're going to use the same numbers each time. Now, in reality, when you make a table, you could pick whatever numbers you want to, but so we all stay consistent and we all have the same image at the very end, we're going to use the same numbers in our chart each time. So our essential question is how do we graph? We're still talking about exponentials, exponential functions, but how do we graph them? What do their graphs look like? So here's our first problem. It's f of x is equal to 3 to the x. That is an exponential equation, and it's an exponential function because the exponent is a variable. It's 3 to the x. So what I'm going to do is we're going to make a table, and we're just going to graph those points that are in our table. So take a second and draw a table, x, and if you want to put y, you can, but I'm going to put f of x. So x and f of x, or you can put x and y, doesn't matter. But so we're consistent, guys. Let's all use the same numbers. We're going to use -2, -1, 0, 1, and 2. And so again, guys, I stress this. You can, whenever you go off and take college algebra, you could use whatever numbers you wanted to. However, so we all stay consistent. Let's pick these same numbers each time. That way we'll all get the same numbers. That way you know you're getting the right things. So what I mean by that is, guys, for 3 to the x, you would have 3 to the -2. For 3 to the -1, that would be 3 to the -1. For 0, that would be 3 to the 0. For 1, that's 3 to the first. And for 2, that will be 3 squared. So you're literally plugging in -2, -1, 0, 1, and 2 into your function. Now, here's how you're going to type it into your calculator. You would type in 3 rooftop. Everybody look for that symbol on your calculator. I call that rooftop. 3 rooftop -2. 3 rooftop -2. And if you type that in, you should get 1/9. That's what your calculator should give you. If anybody doesn't get that, let me know. So 3 rooftop -2. And then you should get 1/9. Now, here's the thing, guys. We want this as a decimal. So, guys, I want you, if you haven't got this already, hit menu, number, and then convert to a decimal. So menu, number, and then convert to a decimal. So, yeah, 1/9. Yeah, and so you should get 0.1. So that's 0.1. So if you didn't get 0.1, that's it. So 3 rooftop -2 is equal to 1/9. But guys, when we graph this, let's do it at decimal points. So put 0.1. All right, for the next one, put in 3 rooftop -1. 3 rooftop -1. You should get 1/3. And then again, convert that into a decimal, and you should get 0.3. So 0.1, then 0.3. All right, type in the next one, 3 rooftop 0. But you should know that anything to the 0 power is automatically equal to 1. So it's just 1. 3 to the first power, that would be 3. 3 to the second power, that would be 9. So really, the only one that you had to use a calculator on was the first 2. Everything after that was pretty easy. What we're going to do is we're going to use these points to graph our image. And so what I'm going to do is go ahead and draw you a little graph over here. It doesn't have to be big, just a little graph. Notice it goes from -2 to 2 on the x-axis. So go -2, +2. So -2 to +2. And notice it goes all the way up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so what we're going to do is we're just going to graph these 5 points. So I'm going to start with the first one. -2, 0.1. Well, -2 is right here. 0.1 is a little bit more than 0, so it's going to be right there. The next one is at -1, 0.3, so it's -1, but it's a little bit higher. So a little bit higher than that blue dot, first blue dot. The next one's at 0.1. The next dot is at 1.3. And the last dot is at 2.9. And right now you can automatically see that pattern, that image showing up. Here would be my completed graph. That is the picture of that exponential function. Now, whenever you talk about exponential functions, there's 2 classifications. It's either a growth or a decay. What would you classify this exponential function as? It's a growth, right? You'll notice a decay because the decay is going down. Exponential functions show up a lot in real life, especially if you're talking about investing like the stock market or retirement funds or 401ks, because anytime you invest money, that is a growth. So hopefully you want your investment to grow, so that's an exponential growth. A decay, anytime you purchase something, like for example, if you purchase a brand new car, it depreciates in value over time. And so purchasing a vehicle and it depreciating over time, that's an example of exponential decay. So growth is going up and decay is going down. But that's as difficult as it gets. What changes is what functions I give you. That's where the difference comes into play. So that's it for this example. All right, let's take a look at another example, and let's just add a little bit extra into here. But remember, you got your calculator, so you can type it into the calculator very easily. So here's your next example. All right, so notice the parentheses, and it's 1/3, and it's to the x. Don't let that frighten you. You can still put parentheses in your calculator. So, again, if you want to go ahead and draw a table, this is no surprise. Always put in the numbers -2, -1, 0, 1, and 2. And again, the reason why we're doing that, guys, is because we want to have a consistent picture. We all want to have the same picture. In reality, you could pick whatever numbers you want to over here, but we all want to have the same picture. So you would have 1/3 rooftop -2, 1/3 rooftop -1, 1/3 rooftop 0. The biggest crucial thing that I need you to see, guys, is that 1/3 is in parentheses. So when you're typing this into your calculator, make sure that you are putting that 1/3 in parentheses. So open parentheses, 1/3, close parentheses, rooftop -2. If you did it correctly, you should have got a 9 for your answer for the first one. For the next one, you should get a 3. The next one, you should get 1. The next one, you'll get 1/3, but convert that to a decimal, so you get 0.3. And then for the last one, you should get 1/9, but convert that to a decimal, you should get 0.1. Now, those numbers should look familiar because I tried to do a very interesting thing. I tried to show you one that was similar to the one you just did, but this one is not a growth problem. This one is a decay. And let me show you that graph for you so you can verify that. So -2 to 2, and it goes from 0 to 9. The first point is at -2, 9, so there's that point. The next point is at -1, 3. The next point is at 0, 1. The next point is at 1.3. And the last point is at 2.1. And so you see it's still that same type of picture, but instead of it being a growth problem, this is an exponential decay problem. And so that's what a decay problem looks like. It's the same pattern, but it's just going in a different direction. It's decaying, it's depressing, it's depreciating in value. So that would be the example of a decay problem. So there's only two types. There's an exponential growth or there's an exponential decay. And you can usually pick up by the numbers if that's a growth or a decay just by watching what your numbers are doing as you go on. So that's an example of each type. Now let me give you an example of one that looks a little bit more complex. But again, don't let it freak you out. Remember, you got your calculator, so you can type this easily into your calculator to get your answers. And just remember, use the same numbers, -2, -1, 0, 1, and 2 every time, and you'll be good to go. No hiccups, no problems. Biggest thing, guys, is watch your parentheses if there are any. All right, here's my next one. I've got 1/4 times 6 to the x. We're going to type this into our calculator, so no worries. All right, and so we're going to tackle this. But again, what I'm going to do is go ahead and make a t-table, x, y, and let's do -1, -1, sorry, -2, -1, 0, 1, and 2. And so what you're going to have here is you're going to do 1/4 times 6 to the -2. So 1/4, 6 to the -2. And then I'm going to make sure that I just type that into the calculator. And so what I'm going to do is I'm going to type in 1/4. So you know how to make a fraction. So 1/4 times 6 and then rooftop -2. You should get, your calculator might give you 1/144. Might give you 1/144. But we want to make that into a decimal. So just convert that and you would get 0. It's going to be really, really small. 007. So it's really small. That's a really small number. The next one, type in 1/4 times 6 to the -1. And so that should give you, if you type that into your calculator, you should get 1 over 24. And then what I'm going to get is 1 divided by 24. You're going to get 0.04. So it's a little bit more, but it's still small. The next one, if you type in 1/4 times 6 to the 0, your calculator should give you 1/4. So that'll be 0.3. For the next one, if you type that in, you should get 1/4. So that'll be 1/4 times 6 to the first. 6 to the first, and that'll give you 6 over 4. So you should get, in your calculator, you should get 3 over 2 if you type that in correctly, and you just get 1.5. For the next one, if you type in 1/4 times 6 to the second, your calculator should just give you 9 as your answer for that. And so once you've got it, then we're just going to plot those points on our graph, and then just go from there. Okay? All right, so when you plot these points, guys, here's what you're going to do. It goes from -2 to +2, and look, it goes up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my first point is really small. So -2, it is almost literally on 0, but I'm going to have to put a little dot right there so you can see it. The next point is a little bit higher. The next point is a little bit higher. Then at 1, it's at 1.5, so it's a little bit between 1 and 2. It's halfway between 1 and 2. And the last point is at 2.9. And so again, it's that same shape, guys. So that's not changing. It's still that same shape, but the points are different. But there's my shape, and that is an example of an exponential growth problem for that. And so that would be my image for that situation. All right, let's do one final one together and just tie this in. So let's do another one where it might be a decay problem, since that was a growth problem. So take a look at this last one. Yeah, right here. All right, so I've got 5 times 1/2. Notice the parentheses, guys. That's crucial. So when you type this in, make sure you use those parentheses. All right, so let's do x and y. So we're going to do -2, -1, 0, 1, and 2. All right, so again, we're always going to pick those 5 numbers, not because you have to, guys, but that way we stay consistent with each other in here. All right, so let's type this in. So you're going to have 5 times, make sure you do open parentheses, 1 over 2, rooftop, -2. So we're going to do 5 times, open parentheses, 1 over 2, rooftop, -2. Your calculator should give you 20. For the next one, 5 times 1 over 2, rooftop, -1. Your calculator should give you 10. For the next one, 5 times 1 over 2, rooftop, 0. Your calculator should give you 5. For the next one, 5 times 1 over 2, rooftop, 1. Your calculator is going to give you 5 over 2. But remember, convert that to a decimal, so you get 2.5. And then for the last one, 5 times 1 over 2, rooftop, 2. Your calculator should give you 5 over 4. But again, convert that to a decimal, it should give you 1.3. And so now we can plot these points on my graph, and notice it goes all the way up to 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the first point is at -220. The next point is at -110. The next point is at 0.5. The next point is at 1, 2.5. And the last point is at 2, 1.3. So it's that same shape. So see, it's the same shape, but the points are different. And this would be exponential decay. And so that's your answer for the